In this video, we're going to create the mesh, run the analysis, and generate results. We will repeat the process in 3 different meshes. First step is to apply initial mesh controls and preview the mesh. Right-click on Mesh and Generate Mesh. This will take a few seconds of time to update. This is what the default meshing scheme will give us, but we need to define the mesh consisting of the T6 triangular elements with the 0.5 inch uniform size. Right-click on Mesh from the tree outline, click Insert, and click Sizing. Click on the Face Selection tool in the toolbar, select the plate, and Apply under Geometry. Set the element size to 0.5 inches. Now, right-click on Mesh, click Insert, and click Method. Same as before, make sure to click on the plate, click Apply. Make sure that the method is now changed to triangles, and that element mid-side nodes are kept. Right-click on Mesh and Generate Mesh. Now the elements are found to be finer compared to the earlier case. Earlier we did not specify the element size, hence the default element size was used for the purpose of creating the mesh. Now click on Mesh, and under Statistics we can see that we have roughly 1700 nodes and 800 elements. Make sure to save the file. Our next step is to insert the desired solution outputs and solve. Right-click on the solution folder under the tree outline and select your desired outputs. For this tutorial, we choose to output the maximum principal stress and the directional deformation in the Y direction. So first we're going to right-click on solution output, insert stress, maximum principal stress, as well as right-click on solution, click insert, deformation, directional deformation, change the orientation to the Y-axis, since with the applied pressure the plate will be stretching in the Y direction. Now select Solve at the top of the toolbar to run the analysis. This will only take a couple of seconds since it's a simple model. For more complex models, we'll have much larger running times. Now, next step is viewing our results. If we click on directional deformation, the deformation is exaggerated, or that the behavior is magnified for clear visibility. It can be seen from the results scaling that it is 670 times the actual case. It can be changed to 1:1 true scale. Click on the animation button and play. The behavior is as expected, though hard to see because deformations are so small. For better clarity, the scale factor can be changed back to the automatic 670 times scale. Let's animate this behavior now. Change the amount of frames to 100 frames and the time to 10 seconds for a smooth animation. This is the behavior that we expected. Once the behavior was predicted to be accurate, we can proceed to getting the plots required for the project. We want to see the plot of the maximum principal stress for each meshing case. Click on maximum principal stress. The stresses generated in this body can be seen. The maximum is seen at the edge of the circle. If you zoom out, you can see it better. From the scale on the side, you can see that the maximum stress is 2,793.7 psi, or 2.7937 ksi. This will be the number you will use to compare the model to the theoretical exact case of 3 ksi to calculate our error. The maximum is seen to be at the edge of the circle, proving that the stress concentration that we had predicted around the circle to be accurate. To capture the stress plot, right-click in the window and select Image to Clipboard. Then we're going to open up a blank Microsoft Word file and paste the image into the Word document to save it. Document what the stress was for case 1, the maximum stress, which was 2.793 ksi. Now we'll go back to ANSYS Mechanical and save our ANSYS file. Minimize the mechanical window and go back to the workbench. In the project schematic, click the arrow in the top left of the Static Structural Analysis A and click Duplicate. This will create a copy of the analysis B. We're going to rename this copy of case 1 to be case 2. Right-click on Setup and click Edit. This will open a new tab of ANSYS Mechanical. The only difference in this case of the model will be the element mesh sizing. Instead of uniform half-inch elements, we will bias the elements from 0.2 inches to 2 inches along the left and bottom sides. Expand mesh from the tree outline, right-click Face Sizing, and click Suppress. Right-click on Mesh of the tree outline, click Insert, and click Sizing. Click on the Edge Selection tool in the toolbar and select the quarter circle and click Apply under Geometry. Set the element size along this quarter circle to be 0.2 inches. Similarly, we're going to control the element size along the top and right face. Right-click on Mesh, click Insert, and click Sizing. Make sure the Edge Selection toolbar is selected. Select the top face, hold down Control, and also select the right face. Hit Apply under Geometry. We have these two edges select, and control the element size on these edges to be 2 inches. Now right-click on Mesh and generate the mesh. Now the elements are found to be finer around the circle and coarser around the top and right edge. Click on Mesh and let's look at the statistics. The mesh contains approximately 600 nodes and around 300 elements, which is much less than the last case, though we have finer elements around the area of concern. Make sure to save the file. Select Solve at the top of the screen to run the analysis. Click on Maximum Principal Stress. The stresses generated in the body can be seen. From the scale on the side, you can see that the maximum stress to be 3026.2 psi, or 3.0262 ksi. This will be the number you will use to compare the model to the theoretical exact solution of 3 ksi to calculate the error. To capture the stress plot, right-click in the window, click Image to Clipboard. Then open up the Microsoft Word document we created before, and paste it in here to save it. The stress for case 2 was 3.0262 KSI. Now we're going to go back and save the ANSYS file. Our next step is repeating for case 3. Minimize the mechanical window, go back into the workbench. In the project schematic, click the arrow on the top left of the static structural analysis B and hit duplicate. We now have a copy of case 2, which we are going to rename case 3. I'll right click on setup and edit. This will open ANSYS Mechanical once again, a third window. The only difference in this model will be the element mesh type. Instead of T6 triangular elements, we will use Q8 quadrilateral elements. Expand the mesh, the tree outline, click on All Triangle Method, and change method to quadrilateral dominant. Right click on mesh, generate mesh. Now the elements are found to be all quads. Click on mesh, and under statistics we can see we have even less nodes in this case, about 460 and about 140 elements. Make sure to save the file. Select Solve at the top of the screen to run this analysis. Click on Maximum Principal Stress. From the scale on the side, you can see the maximum principal stress to be 3047.8 or 3.0478 KSI. This will be the number we will use to compare the model to the theoretical exact solution of 3 KSI to calculate the error. Capture the stress plot. You right click, image to clipboard, go to our Microsoft Word file, and paste it. For case 3, our maximum stress is 3.0478 KSI. The next step is obviously to report the plots and calculate the percent error for each case.